Okay. Also, I borked my laptop yesterday. I don't know what I did, but I got it so that the X server, one of the libraries that it uses, was the wrong version, even though it was system-wide installation. And so when my X server tried to start, it would load up this library and try to link against it, and it would say, this version of the library is the wrong version, and it would refuse to start. Like my freaking X server.
Interesting.
Yeah. So I finally got that working today. But that means that I didn't cover some of the stuff I want to talk about in the slides directly, so we're going to do it live. And that always
That was good, bro.
always ends well.
Now I'm getting bad gateway.
Oh no. For ice?
Yeah.
Damn.
For their one, maybe their.
Have either of you guys started playing the CTF?
No.
No. What's the, oh, you're new, right?
Mm-hmm.
What's your name?
Noah.
Noah?
Mm-hmm.
Okay. Are you on our Slack?
Mm-hmm.
What's your name on there?
Should be Noani1.
Oh, okay.
Oh, cool. Didn't misremember.
Mr. Potts. How's it going? Really good. So just telling everybody else that, well, you saw I boarded my laptop, right?
Oh, yeah.
So, well, I guess I'll just. If this is too dark for anybody, let me know. Yeah, so I didn't get to complete some of the slides I wanted to complete beforehand. So we'll do some of it. I mean, we'll do. I do live demonstrations all the time anyway, but some of it won't have slides to back it up. But I'll update the slides after this.
I'm sure it'll be better than some specific professors doing stuff live.
Some specific, yet not named, unspecific professors.
We are.
I feel like I'm like back in freshman year learning HTML on Code Academy.
Oh,
on
yeah.
the CTF. Oh. Wow, I learned my first programming language, HTML.
Nice.
That was my first on Neopets. that was my first introduction to it. I loved it.
Spoilers. Cool. Oh, I forgot this projector sucks. Alright.
It's not that bad if you're sitting 3 feet from it.
Yeah. What else do I have to do? Okay. Yeah, okay, so I'm just gonna give it like another 3 minutes.
Sure. Will this be difficult to play along with if you don't have Linux in your machine?
So,
Impossible.
I would totally recommend long-term having like a Linux VM or
Definitely working on it, but
you know, Linux
yeah.
dual boot. But also, have you played around with Windows subsystem for Linux before?
I've heard of it. I haven't gotten a chance to check it out yet.
Mm-hmm. It's actually pretty good. It basically, it's not an emulator. It's not a virtual machine. I think I have this. It's I mean, really simply, like an oversimplification would be that it just puts Linux on Windows.
Sure.
Inside of Windows, but it's pretty efficient in the way that it does it. The NT kernel, right, which is what Windows runs on, actually allows you to swap out system call tables and provide an alternative set of functions to reply to system calls. So that's just what it does. It literally exposes like a Linux compatibility layer.
Cool.
Yeah. It's like wine, but backwards. So, oh yeah, I'll make this shorter because there's a CTF going on right now called ICTF. It's broken.
No,
Aw.
it's just fine.
Oh.
Just the one challenge I wanted to do is broken. It's okay.
They are technically limiting teams to 3 members. So, it seems like Kevin started already. And if it's just the 3 of you for today, I would totally recommend making a group. And I could unofficially offline help you a little bit if you want. But it's a really cool CTF. They usually have a really good variety of challenges from beginner to advanced. So I think no matter your skill level, you can definitely learn something from this one. There are other CTFs that, yeah, you can definitely learn stuff from them, but the challenges are all very hard. Seesaw next weekend is one of those. Like you can definitely learn something from it, but it's really hard to solve one challenge even. So this one's not like that. If you can get it to work, apparently.
Yeah.
So email registration is successful. All right, whatever. I'll do that afterwards. Oh, is this their sponsor?
Mm-hmm.
Okay. Hey.
Hi.
Hello.
You're here for White Hunters?
Yeah.
Great.
Welcome to the party.
Thanks.
What's your name?
Julie?
Julie. Oh yeah, I've seen you on Slack.
Yeah.
I'm Kevin.
Oh, okay. I'm Noah. All right.
What's your name again?
Oh, mine?
No, I was. What's your name?
I'm
Kevin. Other Kevin. No, just Kevin. And yeah, why don't we introduce ourselves?
Hi, I'm Tom.
Hi, Tom.
I'm William.
Awesome. Yeah, so last week, actually, I think I'm just going to share this entire folder. How does one share a... Oh, share. Okay, link sharing on. Cool. Come on.
Oh, there's a desktop app for that?
Yes.
No.
It's literally just a web app bundled with a kind of portable version of Chrome called Electron.
Okay.
Exploitation meeting. Let's put this in exploitation meeting. So anything specific to these meetings, I'll probably put in this channel. So why did that give a link to just that file? I guess I have to do that to one of these. There we go. So that has last week's, yeah, that's fine, but that has last week's slides. But this week we'll recap some of it. So yeah, okay, let's get started. So, William, were you there last Friday?
No, I wasn't.
Okay. Kevin, you were there last Friday.
Was.
What did we talk about?
We talked about buffer overflows
Yeah.
and the stack in general.
Yeah. So buffer overflows are when you write a bit of code that I should get my good markers. It's purple. You can see purple. So buffer overflow is when you write a bit of code that allocates space for an array, and you know, I might put anything in here, maybe even like characters. Like let's say I store the characters HELLO. And then the way that you use strings in C, it's always an array of characters, but it almost always has a 0 at the end of it. Or sometimes you'll see this represented like this. So if you ever see like a character that \0, it's just an actual number 0. So buffer overflow attack is when you take a pointer to this array and you send it to somebody else, but you either don't tell them how long it is, or you tell them an incorrect length. And what they do is, for some reason, they modify the array, but then they go past the end of it and start modifying these values. Even though you didn't allocate that space, you never claimed it as yours, and yet somebody's still modifying that. So that's what a buffer overflow is. And typically that's a bug. You'll be messing with other variables that you didn't want to modify, and it might cause your program to crash. But it can be exploited. It can be considered a vulnerability if these are some very specific values that, if they're changed, or these are some very specific variables that, if they're changed to very specific values, you could manipulate how the program executes. So let's think of an example of a program that might be exploitable if you have a buffer overflow vulnerability. So say I have like a web server that you can have a client computer, right? So this is your browser. It asks the web server for a page. Say like it asks it for index.php or something. And the web server sends back, the page that the browser requested. But what if the web server takes the name of the file and copies it into, let's say it allocates, like 1,000 elements for a file name, right? And then it takes the file name that it got, and it copies it into this array, right? So we'll have /index.html followed by like just a bunch of zeros, right? So that's fine. But what if the name of the file that I give it is really super long? Well, then it'll fill up the rest of the array. Like, what if I give it like .html, astif, foo, hello, pound, you, right? That's a buffer overflow, right? So the problem with this is that the only way that the browser should ever be able to affect what the server does is by selecting which file the server returns. But by triggering a buffer overflow vulnerability, you could be overwriting some other variable in the server. Like maybe this is where the administrator's password is stored. And if you overwrite it, now you can like log into the admin page with the password that you just overwrote it with. So that's an example of how it could be exploitable. So you can cause programs to do things that they weren't intended to do. Is the basic idea of a vulnerability. So let's recap from last week. So last week, you don't really have to like memorize this entire flowchart or anything, and the slides will be online later. But basically, the two things that we really, or really the three things we really care about when we're programming is we care about the source code because that's the easiest way for humans to understand what a program is doing. And then through a bunch of compilation processes that eventually gets translated to our program. And that program gets run on the CPU, right? That's just this. You can think of it like a black box, right? That is really hard for a human to figure out what it's doing, but for a CPU, it's the easiest way to tell the CPU to do a series of things. Okay, but what if we want to figure out what it's doing without actually looking at that binary? Well, one of the intermediate steps is called assembly. And a compiler's job is to translate a program from one language to another while keeping the meaning, keeping the semantics the same. So these should be equivalent programs, just in different languages. This is what we wrote, and this is a target language, right, called assembly. But the nice thing about assembly is that there's pretty much like a one-to-one correspondence between assembly and binary. Like, there's very little that could be different between assembly for a program and the program itself. So the nice thing is that as humans, it's more readable than binary is. And it's more low level than C source. In C, you could just say, hey, I have two numbers, add them together. But in assembly, you have to say, oh, I have this number in this specific address in memory. I want you to move it into this register on the CPU. And then I want you to do the same thing for this other number into this other register. And I want you to add the registers and then write it out to this other very specific place in memory. And when we're reverse engineering a program, that's really important because there might be a vulnerability that's not like a logical fault in the source. So like a logical fault might be like if I don't know, something stupid even, if password doesn't equal user entered password authenticated, right? So this is saying like, if the user entered the wrong password, they're authenticated. This would be a very obvious logical error, and we can see it in the source code. But some of the more fine-grained vulnerabilities, it's a lot easier to look at the assembly to figure out what's wrong with it. So that's why we care about assembly in the first place. Any questions so far? Next slide. So there are two major, you can call them flavors of syntax for representing assembly. And this is really for representing what's called x86 or x86-64, or sometimes called AMD 64, or sometimes called x64. This is Intel's original instruction set that they created back in the 70s for their 8086 processor, right? Intel 8086. And then they liked it so much that they used it in their 80186 processor, and their 80286 processor, and their 80386 processor, and their 80486 processor, and they codenamed this one Pentium. So this is a processor that probably a lot of us have actually had computers that had a Pentium chip in it. After the Pentium was like the Pentium 2 and the Pentium 3 and the Pentium 4. And then we've had other chips, and these days we have, we have the Core, not the Gore I series, the Core I series chips, right? Right. So if you ever hear the terms like i3, i5, i7, these are modern Intel CPUs, but they all follow supersets of this original instruction set that Intel drafted in the 70s. But they follow a slightly different version of it. So, man, I don't remember what year AMD came out with. So AMD took x86. Actually, so Intel, so x86 is 32-bit. That's a 32-bit processor. That means that like all of the registers on the CPU can all store 32 bits each. Intel wanted to make a 64-bit instruction set, which just means that the register sizes on the CPU they can store 64 bits. For a variety of reasons. One of them means that you can address a huge amount of memory. Another is that some operations become faster, especially if you're working with really large numbers all the time. So they took their x86, which is a 32-bit instruction set, and they made I think they called it IA64.
Yeah, it was like Intellium, right?
Right, yeah.
Titanium.
Titanium,
Yeah,
exactly. And instead of just taking their x86 instruction set and like adding on instructions for 64-bit stuff, they just made it completely different, which obviously the industry didn't really like because a lot of people got used to programming in this, and then they're like, Intel, why did you make something completely different? You know, we've been using this for like 15, 20 years. So around the same time, AMD made a competing standard called AMD 64, which, so if we have x86 instructions, we have IA64 instructions, and there might have been some overlap, but for the most part, it was a different instruction set. I'm not actually sure about this, but if there is an intersection, it was really small. Essentially, this wasn't a superset of x86. There are a lot of instructions in x86 that didn't exist in IA64. But what AMD did instead is they made AMD 64 a superset of x86. And everybody loved that because it meant that you could take an x86 program, a 32-bit program, and just run it on an AMD 64 processor without any modifications. And you could slowly branch out even. So this kind of died. It's still used in a few like legacy devices, but any 64-bit laptop, desktop you buy today is going to be an AMD 64 processor. There's some other, there are ARM processors made by a company called ARM. There are MIPS processors. I don't remember, what's the name of the guys that makes MIPS? Yeah,
I should know.
You should know?
I should know.
These are used on a lot of, ARM is used on mobile devices a lot, and both of them are used on like routers and like IoT devices a lot. But laptops and desktops tend to use AMD 64. Anyway, there's a huge debate, not a huge debate, but there are two ways of writing assembly for x86 programs. And one of them it's called the AT&T style, and one of them is called the Intel style. I don't know the histories about them because I only care about one of them, and that sums it up pretty much. This is AT&T, and this is Intel. What does some of you guys notice about the differences between the two? It's the same program, by the way, just two different ways of writing it.
Top one's pretty ugly.
Pretty ugly, right? You have these superfluous dollar signs, percent signs. Yeah, what else? What's another thing that looks kind of annoying, maybe?
The Q and everything.
The Q on everything! Like, every single instruction has, like, an extra Q. Like, what the heck is that? Well, what this is saying is that it's operating on 64-bit values. Instead of the traditional MOV instruction, it operates on a 16 or an 8 or a 32-bit operand. So for whatever reason, when AMD 64 came out, the AT&T style, whoever designs the AT&T style syntax decided to add Q onto everything that operates on 64-bit, whereas Intel was like, no, you can just use the same instructions. The assembler's smart enough to know what you're trying to ask it to do. So just for those reasons, Intel's a lot easier to read and to write. But the biggest difference between them, which is pretty much personal preference, but most people find themselves getting used to one or the other. In Intel style syntax, the destination register is the leftmost, and then the source registers are all the rest. Whereas on AT&T style syntax, the source registers are everything except for the last register. So like in this case, the last register is here. Well, that's not the same instruction. Here's the destination register, and the source registers are everything before it. So this kind of corresponds to C, where like usually in C, the destination, like if you have a function that takes a bunch of values, computes some result, and stores it somewhere, you usually put that destination as the first argument, and then all the operands, or all the input arguments, all the rest. So this kind of maps more closely to C, but it's just personal preference in that regard. But you do have to be watching out for that, so you don't get bitten in the butt. Like, wait, why are they moving the value of REX into the number 63? Like, that doesn't make sense. Numbers can't store things. And then I think, yeah, this was just a funny comment on Reddit. AT&T syntax needs to die in a nuclear fire. And he didn't write it in AT&T syntax, so some guy fixed it for him. So, okay, and then last week we also talked about the concept of a stack. Who can tell me what, I mean, if you didn't see this right here, what's a stack also called sometimes?
Last in, first stack?
Yes. Sometimes it's called a LIFO, last in, first out, or a what?
Push pop.
A push pop.
The little.
Yeah. Man, I kind of want one of those now.
Yeah.
Sometimes it's also called a philo or philo, first in, last out. Basically, the two things you can do on a stack are, it's basically an array of elements, or, I mean, it doesn't have to be an array. It's some sort of sequence of elements, such that you can add an element on or remove an element. But in order to, this is tough, like, because, okay, so when you push an element on, you can think of it as, it has like a top, right? It has a current top. And when you push an element onto it, you basically move that top. You give it some room, and then you copy that element, right? So this thing is getting copied into this place. And then when you pop an element off, you take this and copy it somewhere else, and then move that top back down to where it was. So that's pushing and popping. And this diagram really kind of sums it up very well. These items look like they're being added on top of the stack, and then popping is removing the top items off. But the basic concept of a stack is that the oldest items don't get removed until the ones newer than them do. So, yeah, I mean, that's what a stack is. The opposite of that is a queue, where you can add items onto it, and then when you ask it to remove an item, it removes the oldest item instead of the newest item. So that's just what it is, and then why is that important to what we're doing? Okay, yeah, this kind of explains it. So when I'm in main and I want to call this other function, well, actually, let's say that main has like a couple variables, int a, b, c, and I call do hello that also has like an int a, b, c. Well, if I wanted to store something here and then call this function, do I want this function's a, b, and c to be the same as this a, b, and c? Should they refer to the same? Oh, no, right? Yeah. That's why we call these local variables, right? Because they're local to this function. It means that nothing else should be able to touch it unless I pass a pointer to it, to someone else. So that means that whenever we call a function, we need some way of saving all of our current values. So the way that Linux programs do this is that whenever a function is called, there's a global stack, and whenever a function is called, it knows how many local variables it has. So in this case, 3. And it knows the size of each of these variables ahead of time. I mean, the compiler knows that. So when a function is called, it makes some space on the stack for its, let's say, like local variables, right? And this is mains frame. Right, so this is A, B, and C in main. And then anytime it wants to call another function, it calls that function, and then that function makes some space for itself, for its local variables. Do hello frame. Right, so that's, and then once do hello is done, what do you think it's going to do with all of its variables there?
Pop them off.
Pop them off, exactly. So you can think of it as I pushed on some space onto our stack for do hello's A, B, and C, and then when do hello is done and it's going to return, I need to pop them off so that that space isn't wasted and that main can then access its A, B, and C. So how's this done? In C, when we're about to enter main, we have this register called RSP, if you're on 64-bit, or ESP in 32-bit mode. But whichever one it is, basically it points just below the start of the stack. And this is the case for RSP and ESP always. They point at the topmost item in the stack. And when you have no items, you represent that by it points below the stack. And then when main wants to push A, B, and C on the stack, what it does is it executes an instruction, and this is an oversimplification, but say it says push 5. What that does is the processor will increment, or it'll move RSP up the stack by 1 element. So it points here, and then it'll store the operand of that instruction at that point. And then it can push 4, and the same thing happens. We move the stack, right? Oh, SP stands for stack pointer. We move the stack pointer up 1 and then store a 4 there. And then same thing, like push 3, move the stack pointer up an element, right? Move it up an element and then store 3. All right, so that's concretely how we store values on the stack. And then if we want to pop them off into a register, we say pop, and then we give the name of the register, let's say RAX. If you weren't there last week, we have 4 general purpose registers. And then a few others that are also used really commonly, RDI, RCI, RSI, and then R8 through R11 or 12. Does anybody remember? Well, you definitely have R8, 9, 10, 11, but it might go higher than that sometimes. That's in 64-bit mode, and then in 32-bit mode, all of these are the same, except get rid of the R and make it an S, or I mean make it an E. So you have EAX, to EDX. You have EDI and ESI. But yeah, so the pop instruction takes the name of a register, and then what it does is it looks where the stack pointer points, copies it into that register, and then moves the stack pointer down 1. And so note this is really a copy, right? So it doesn't change the contents of memory at that location, even though this is now considered outside of the stack, right? Typically, we don't want to care about stuff that's higher up the stack than the stack pointer. So a lot of times we'll just erase this because it's now deallocated, but there's a ghost of a 3 living there still. That's important in some advanced challenges sometimes. So that's how the stack works. Questions? Okay. Now I know, like this stuff will get pretty deep. It can get overwhelming, but like practicing in CTFs and pwnable.kr. Pwnable. Kevin showed me this. This is an awesome site that just 24/7 has pwnable challenges that you can download, and then it gives you credentials to a server. You log into the server and try to hone that program. What's China's version of that?
I don't know. I haven't seen that. I know there's a pwnable.vn, I think.
VN?
That has, it's all shell code.
Okay.
I think it's VN. I'll check real quick for you.
Yeah, there are a few sites that basically just have 24/7 CTFs going on, and you can just download the programs and potentially the source code, figure out what's wrong with them, exploit them, and gain imaginary internet points. And knowledge.
Points though.
But the points.
Yeah.
Everything's made up and the points don't matter.
If you can do, it's TW is the one with all the shell code.
Okay, so
If you can do the challenges on pwnable.kr, you're like set for CTFs. Because they start to ramp up in difficulty.
yeah.
And if you can do them, you know you're good to go for challenges.
Yeah, the pwnable.kr separates it into like difficulty levels. Baby's bottle is the first level of difficulty.
And it's not actually a baby's bottle,
Yeah.
despite what they call it.
I wouldn't call it easy. I mean, if you like have experience with all of this and you find the vulnerability right away, maybe it won't be challenging, but it'll definitely not be easy. Even if you know exactly what's wrong with it, you still have to work to find the solution. That being said, if it's your first time with CTFs, it will be challenging on Pwnable. But you can definitely learn some awesome stuff with it. So that being said, so we know how to push stuff on the stack and pop stuff off. So let's get function calling actually working now. So I want to call do hello, right? And let's say that this is what main's stack frame looks like. So the very first thing that I need to tell do hello is where to return to. Because my main is really simple right now, but if it has more code later on, after do hello is done, when it wants to return, it needs to know where to go, right? Because normally, like the CPU will just execute instructions one after one after the other, right? So like in this case, if do hello just like doesn't return, we might like re-enter main from the start, and that's obviously not what we want to do, right? So we need to tell do hello somehow where to return. So in that case, that's whatever follows right after the call to do hello, right? So let's call this our return address, and let's just store that on the stack, I guess. Return address, right? So you can think of this as like there's another register called RIP. Again, 64-bit calls it RIP, 32-bit mode calls it EIP, and that points, so if we have our instruction stream like push 5, push 4, push RIP, push 3. RIP, when you're executing an instruction, always points at the beginning of the next instruction on x86. On other architectures, it might work differently. But the instruction pointer on x86 always points at the next instruction while you're executing a current one. So that's a problem, because what if we wanted to do something like push RIP, call do hello, Well, what'll happen is, and then let's say that this is what main does, and then let's say that do hello, it does some stuff, and then it pops that value that we pushed on into the register RIP. You can't actually do this on x86, but let's just assume we could. What'll happen is main will push, where will RIP point to when we execute this instruction? Yeah, the call do hello, right? RIP will point here. So we'll push pointer to here, and then we'll jump into do hello, it does its stuff, and then it pops this value off into RIP, which would return to here and call do hello again, which is not what we want. We want it to return here, right? So instead of having this push followed by a call in x86, it's wrapped up by, well, actually, let's call this a jump. Because these two are bundled into one instruction called call. So we wouldn't write this. Instead, it would be just call do hello, followed by the rest of main's code. And then do hello would do some stuff, and then execute this instruction called ret. So what do these do? Call does basically what we saw before, except now it's only one instruction. Now RIP will point here when we execute this. That's great because call hello, or call do hello, it'll push RIP. So the call instruction, it pushes the current value of RIP, and after that it jumps to wherever we tell it to jump, all in one instruction, which means it'll push RIP. So now our return address will point here, and then it'll jump to wherever we told it to jump, right? So now it'll jump here, execute do hello, and then what the ret instruction does is in one, I mean, you can think of ret as equivalent to pop RIP. Even though this technically isn't valid, that's basically what ret does. It takes wherever RSP points, it copies the value that it points to into the instruction pointer, and then moves RSP down one. So that's how you call functions on x86. But then today I wanted to quickly talk about how you pass arguments into functions in assembly. But before I do that, questions on this, because I know there probably will be some. All right. These slides, I mean, it's in the link that I posted, so if you ever want to come back to it. Oh, that's right. I guess I stepped through it last week, but running a little short on time. So I'll skip this for now. But you can step through this animation and see exactly what happens on the stack. So we figured out how to call functions, but we don't know how to pass arguments into them yet. So on x86-64 or AMD 64 or whatever, before we execute that call, so let's say we want to instead, we have our main, and it wants to call this other function with 1, 2, and 3. And then we have this, we have a void f, it takes an int a, an int b, and an int c. And then let's just say it returns 5. So before we call f, we need to store its argument somewhere. The way that x86-64 does it is it has these registers, RDI, RSI, RDX, R6, R8, R9. Don't have to memorize them. You can Google it or refer to the slides or whatever. And it stores the first 6 arguments here. So in our case, 1, 2, and 3. we would store these here, here, and here. What does that look like in assembly? It's move, so, I don't know, can anybody fill in the blank? What are the two operands to the move so that we copy one into A, or one into RDI?
RDI is the destination, right?
RDI is the destination, so Intel syntax. Uh-huh.
And then A is the what's being moved.
Yeah, so A is what's being moved, but it's just a constant value of 1.
Sure.
So the compiler would probably use that constant value, so the 1, right? And then same thing, so move RSI2, and then move RDX3, right? So that's how x86-64 handles it, and then we would call F, and then, so this is what main does, and then F, what it does is it returns 5, and I don't think it shows it in this diagram, but on both x86, 64, and just x86, the way to return a value is you move the value you want to return into AX. If it's 64-bit, RAX. If it's 32-bit, EAX. You remove, so what would we want to return? 5, right? So we move the value 5 into RAX and then return, right? So on a 64-bit CPU, this would look like that. I think. No, I mean it wouldn't because this is void. You can't return a number from a void. But if we make it an int, now it would look like that. Yes. Questions? Okay. The 32-bit version is even simpler than that, actually. I don't like diagrams like this because I forgot to tell you, but the stack, I always draw it so when you push something, you add on top. When you pop something, it removes from the top. And that's the typical way in computer science you draw this. But for whatever reason, Intel decided to make this a high address and this a low address, which seems fine, right? Because typically, like if you're reading something, you think like low should come before high, and you're reading it top to bottom. But the problem with this is that when you push something onto the stack, RSP actually gets smaller, right? Because to move up the stack, you have to decrease the value of RSP. So because that's kind of confusing, some people will draw their stacks upside down and say, oh wait, no, this diagram's fine. Higher address at the bottom, lower address at the top. That's how, when you're talking about poning binaries, this is the easiest way to think about things. So remember how on the 64-bit version, the first 6 values would get passed in registers? I didn't tell you that arguments 7 and beyond, we would push those onto the stack, right to left. Well, x86 is a little bit simpler because it just pushes everything, right? So if we have our function called f123, we would just push the values onto the stack. So push 3, push 2, push 1, and then call f. So this is even simpler because you don't even have to count, oh, is it one of the first 6 arguments? Well, I put it in the register. Oh, is it 7 or beyond? I push it. x86 just pushes everything. It's a little more inefficient. That's why they decided to pass the first 6 arguments by register. But that's all. So we push our arguments and then we call. So we figured out how to call functions. We figured out how to call functions with arguments. Last week I showed you guys how to use a buffer overflow vulnerability to essentially return into a function that you weren't supposed to be able to execute. And last, that was, all right, Slack just stopped. what did that look like? Oh yeah, that's right, it's on a previous slide. So last week that looked like this. We have this function called super secret shell that if this ever gets called, it gives us shell access to the system. And yet this function is never called in our program. So remember when we call do hello, the first thing it does is it makes room for its local variables, right? And if somehow, remember the buffer overflow vulnerability, if somehow we get do hello or someone else to write past the end of this array into the return address, if we can write a very specific value, that means that we could, for instance, write the address of super secret shell. So that when do hello executes the ret instruction, it'll pop this off the stack and return to that address, which ends up executing our super secret shell. So last week I showed you how you can overwrite the return address of a function on the stack to return to some bit of code that will give you enhanced privileges or, in this case, shell access. Basically something that the program wasn't supposed to do. Like maybe a more reasonable case is like if password good, then authenticated, else error. So this is a little more reasonable, right? Say this is like some function. I haven't given a name yet. So if the user typed in a good password, they're authenticated, they can do whatever. Otherwise, return an error. So that's kind of reasonable. But the problem is that if the function like earlier on had like an array allocation, and then let's say it points it, or it passes that, or a pointer to that array into this function. If somehow we can get the program to, say that in this case it's not name, but it's password, if we can get the program to write what it thinks is legitimate data past the end of password, we can overwrite return pointer. So this function will call error, but as long as error returns, when we return, we could return to anywhere. Even like, maybe I point this at the authenticated function. So it'll print out an error, but then after that, it'll give us a shell or something. So that's if there exists code in the program that we would want to force the program to jump into. That's how you would use a buffer overflow vulnerability to gain control of the program. But what if there isn't any code in the program that is interesting? So earlier we saw a traditional stack overflow, what do they call this? A stack overflow attack. It's a buffer overflow attack. So we would overwrite the return address somehow, so that when the function returns, we can get it to go somewhere that we control, or that would give us control, or something like that. But in a different kind of attack, we might want to keep writing past the end of the return address and put code there. In the past, we've only been storing data on the stack, but I mean, code is just all this assembly, right? We saw earlier gets compiled into binary, right? So it's code is data. So we could compile a program of our own, take that binary, and then shove it into the other program as data. So we could store code on the stack, and then we can get the return address to point to that code, so that when we return, where would we be returning into? We'd be returning into this code. And what would happen, that means this code starts getting executed. So we could put arbitrary code on the stack and get the program to return into that code. So this is code that didn't exist in the original program, but we injected it into the memory space of the running program. So this attack is called a stack smashing attack, and now I can erase my fix, right? So it's called a stack smashing attack. Yeah, geez. Okay, so that took about 55 minutes. I wanted to kind of show what a stack smashing attack looks like, but I also wanted to get everybody started on ICTF. So I think next week I'll show everybody what how to pull off a stack smashing attack. So sorry there wasn't any hands-on demo this time, but I really want to start playing ICTF because I think this would be really great for everyone. So 1, 2, 3, 4, 5, 6, 7. Okay, so let's do a team of 2 teams of 3 and a team of 2, I guess. Okay.
I already signed up if that helps.
You already signed up? Okay, so 2 teams of 3, right? 1, 2, 3, 4, 5, 6. Okay. So let's do the 3 of you on a team and the 3 of you on a team. So if one person from each team could go to icec.tf. Sheesh. And I actually haven't. Oh, I think I just did sign up. Sign up. Company. Should I put Google? Google.
I swear it's legit.
Stop Chrome. Jeez.
Yo, that last pass though.
So I guess you guys get to see my first 20 characters of my 100 character
Whoa.
password.
Overkill.
There are no open invites. Okay, so then. So, okay, actually, I guess everybody needs to make an account, I guess, and then what you invite people to your team. Is that how it works?
Yep.
Okay. But I guess once you do that.
I think if you click ICTF, you can view the board that we need.
Okay. Okay, I'll just make a.
When you finally do join the team, they just leave you on this page. And there's no compete button.
Aw.
Which is annoying.
Oh, I'm in 663rd place. Wow. I've done nothing.
Cool. Will our usernames be seen by anyone?
Probably.
I
At
wonder
least
if I
your
can
team.
leave and join.
At least your team
I
can see.
think they appear in the leaderboard.
Do
Okay.
they? Okay.
Cool.
I haven't confirmed that for myself, but I know that they have a leaderboard of like
Will our
everybody
emails be
that's
seen by
there.
anyone?
I have 10.
No,
Don't
I
think
it
so.
would be.
Cool.
So, are they doing like?
It looks
It's a
like
bit
an
different.
Academy. It's kind of awful in my opinion.
You
Really?
can't see like who solved what
No.
or anything like that.
So you
You
have
just
to
see the
unlock
top 10.
challenges as you go.
Oh, I don't know about that.
Oh no,
Okay.
you can see everybody.
Okay.
You can do all the challenges right away.
Yeah, I think that's all the challenges. There just aren't many in each category.
Yeah.
So
They don't tell you who solved it or anything like that.
that's silly.
Yeah, there are no
Um,
stats on that.
So this looks like a very minimalistic or like head start. Okay. Other CTFs are usually a little bit simpler, but they give you more info. I don't know. This is just a little bit different. But it's similar to other CTFs in that like there will be like a board with categories, and then you'll have challenges within those categories. Like in this category, web, we have, we only have one challenge so far. Okay, start.
Code Academy.
Oh, geez, are you serious?
Literally is Code Academy.
Okay.
They used a,
You
well,
use
they used a
that
platform
giant
called
button to download things,
Adversary or something.
which also takes you to the website.
Okay. So
Not an endorsement.
there's something wrong with this website besides its content. I'm not falling on either side here. But yeah, so web challenges, there will be some vulnerability baked into the website. Thanks. I like it. I like it. I would really be interested to see, like, sometimes, like, there will be like, people can make blog entries and then other people can read them, and like sometimes they'll have like blog IDs, like, so I wonder if there's anything in here with, like,
As far as I can tell, this has nothing.
that's blog number 420. Hey. Oh. Well. I don't know. I'm really bad at web challenges. I don't know.
That's a good idea. It was
Robots,
/tote.
Texts. Really original. I don't know.
There is a hello world under miscellaneous that
Yeah, if you want to solve a
Kinda
challenge,
starts
there's a
you.
whole.
Okay.
shows you the format. and
Is that
everything.
is that like kind of easier?
Well, it's just yeah, it's just trivial. And
No,
then-
it's pretty hard.
Oh, if it's 10 points, it's going to be extremely hard, right? Way too
I don't think there's anything to download on that one.
Oh, okay.
Just
Oh,
read
welcome.
instructions.
Let me zoom in a little bit. Welcome. All flags. Oh yeah. So in a lot of CTFs, the ultimate goal is to drop a flag, right? Capture the flag. So we have these strings called flags, and a lot of times they'll follow a format like flag. I don't know. Never. It looks like a really bad 3. Never use. I don't know. PHP or something. So a lot of times they'll look like that, or instead of flag, it might be like, whatever CTF, whatever the name of the CTF is. And most CTFs will tell you what the format for the flag is. So they say it's ICTF, curly brace, secret message, and then a curly brace. And then they tell you how the specific CTF works. And then for this challenge, they give you the solution to the challenge. So you say, oh, I got the flag. I don't know how I got it. That was really challenging.
You can write a review.
5 stars. Although simplistic in nature, this challenge is quite edifying. I don't know how to spell that right. I don't think that's how you spell edifying, but whatever.
Your review was received.
So let's see, let's just see if there's like an easy.
That's the one I'm working on.
Pokemango.
Yeah, it's an Android one.
200 points.
Android app.
Might not be that hard. I stumbled upon a strange website. It's made by a flower enthusiast, but it's taken over by someone or something. Can you figure out what it's trying to tell us? Nothing, because I can't click on it. Oh God.
Oh no, you've been hacked.
Send us Bitcoin. This challenge makes me want to cry.
Attach princess. Fail.
Yeah, okay. Wow.
What happened to this site?
Countdown. Okay, we have 195,000 seconds.
All right.
How long is that? That's like 50 hours? Is that it?
135 days.
Oh, no, that appears,
500 hours
Yeah,
probably.
that appears to be the days though, because the seconds.
Oh, you're right.
You're right.
Yeah, wait, seconds, minutes, hours, days.
Presumably, yeah.
Okay, well,
Okay.
we have a really long time to solve this challenge, I guess. But
Yours is that.
with web challenges, one of the first things you do is you look at the source code for it. In Chrome, you can right-click, inspect, or Control-Shift-I is the shortcut for that. And I don't know, this is a 200-point challenge, so it's probably not trivial. But I don't know. Let's look at this element specifically. Okay. They're just like these weird. They look like shell commands, but they're not. And we have a link to a script. So takes the current date, India time. Is that some global?
IST is about 8 hours off-ish. I mean, it's like 7 p.m. there and 9 a.m. here.
Yeah, okay.
There we go.
So I guess the idea is that this challenge was taken over by some hacker in India or some guy trying to look like a hacker from India, I guess. Takes the difference between them. It looks like it's just counting down, but there might be some logical error with this. Like there might be some weird edge case that it skips a second or something silly. But this looks like all it's doing is
If you
running out the countdown.
If we go in back to the page and change the counter variable to 0 or something.
India time. India time. Oh, what is it? Is it date time? I don't know JavaScript. New date. Zero. So we know it stops at 0. It doesn't seem to do anything visibly interesting, but that doesn't mean that it's not doing anything interesting at all.
I guess if it did anything interesting, we would have seen it in the code. So.
I don't know if this is an error with the challenge itself, but for whatever reason, it requested a GIF from the server, and the server said that GIF doesn't exist.
Yeah, all of the links give that.
Oh, really?
Like if you click on About or Home or Gardens,
Oh, yeah.
it gives you that.
That's bizarre.
It is.
But
I fixed it.
I just deleted it.
Yeah.
But yeah, it's hard to know whether or not that's part of the challenge or if that's a mistake.
It's like
Yeah, I was really kind of hoping there'd be like a really easy, like just intro, like clonable challenge. So, I mean, again, so these look like they might be challenging, but doable. So forensics is like basically somebody has, I don't know, we got some file off some guy's computer, but he like wrapped it in a bunch of layers of zip files, and he like modified an image so it stores text in it, and I mean, I guess that would be more steganography, but it's basically like there's data in this, and we need to figure out what the data is. It looks like it might just be the
like what
individual strokes.
individual layer, like layered them all on top of each other. What would we get?
Yeah, let's yeah. There's a way to open.
I need to learn how to do
From
these
clipboard?
challenges.
What is it?
From clipboard or?
I thought you could. Oh, here.
Oh, okay.
Open from URL. Ah, screw it. Yeah, copy. Can't type. Oh, okay. Well, I guess I can just move it in here. Couldn't. Oh my gosh. Download. Save it as desktop. Go to my desktop.
So when you Google anything GIF, it just gives you that thing GIF. So I'm googling like flatten, unroll GIFs, and it's just giving me like paper unrolling
really?
and shit. Like this is a difficult thing to search for.
Interesting.
How to
Um,
roll.
I thought there's a way.
That cannot be determined.
I want to convert all of these. Let's do colors. Or something. Color to alpha. Yeah, why can't I oh, I need to add an alpha channel. Basically, in order to solve a challenge like this, like, you just need to know how to like screw around with image manipulation stuff, I guess. Oh, I need to remove the alpha channel. So basically what I'm doing with this is I want to... Alright, why can't I color to alpha? I want to try converting everywhere where it's white to invisible. Alright, well this is dumb. Delete. But I don't have an alpha channel anymore. Delete. Okay, so let's try with the next layer. Everywhere there's white, delete.
Nice.
White, delete.
Can you select multiple layers?
I wish I could. I wonder.
It's just literally just on that like panel to shift like multiple layers at once.
I couldn't.
No.
But then you would
No.
have to select the white on that layer, though.
Yeah, I guess.
Thank-
But you could write a script to do it, because there are like hundreds of layers, and this could get kind of annoying. But I'm just looking for like any sign that this is the right way to proceed.
Seems like it.
And I don't know. Yeah, it might be. Some things seem to kind of line up.
Yeah.
Oh yeah,
Yeah, there
that
we go.
lined up, right?
That's it.
Yeah. So
Cool.
Pretty sweet.
I don't know if it's faster to write a script to do this or
Yeah, you're like halfway done already.
not really. But this seems to be the right solution. So if anybody feels like,
Pretty much.
I can imagine that starting to spell ICTF.
you think? Oh God.
That's probably faster than this. Finding a way to make the GIF go way faster.
Oh, true. I don't know. This might not be
now it's
right.
starting to get...
Oh well. Oh no, I see. ICE.
Yeah.
Yeah. Okay. ICE CTF. So yeah, I guess that's probably it.
And
Those
there's a
colors are
bracket.
probably anomalies, like just
Probably.
I guess-
to throw you off.
Actually, we actually kind of are like halfway through.
Sometimes.
You definitely were not halfway through when I said it.
This is a touchscreen. Aha.
Elite hacker right there.
Oh no, I don't want to reorder them. Whatever. This is like. I can't believe I'm doing this.
Yes. If you had some sort of like image filtering script, you could tell it to replace
Yes.
all the white with
You
transparent.
know who's
right?
really good with those?
Yeah.
That's
Yeah, he's good with those. There are like Python libraries and libraries in other languages for image manipulation stuff. A really good one for Python is called Pillow. So I would literally just be able to loop through all of the layers. Wherever there's something that's white or really close to white, just change it to completely transparent, merge all the layers into an image and export it, and then I'd be able to view it. But it actually probably honestly take about the same time to write that as it does to just manually do it. If this were like 1,000 layers, obviously that'd be way faster.
How many layers is this?
A lot?
Almost done.
67.
Oh.
15. So this says ICTF wow,
Wow.
fast?
wow.
Is that what it says? Wow, Ethan. Great news.
Keep it up. Proud of you.
Yeah, I guess wow fast.
Wow, fast.
All right. I can't tell if it's an ice or a once, but they did say in the rules that it would be ICE. So let's try that, I guess.
Wow.
So I guess I like technically cheated because like we're not supposed to share flags across teams, but since I haven't joined a team yet,
I mean, a couple of us like yelled out like move the map in like the same time,
Hey.
so.
yeah, okay. But that's like you'll see some what was this, forensics. This could be forensics, or this could be another category called steganography. But steganography is more focused on.
There's some psycho challenges.
Is there? Stego is like hiding data in plain sight. Forensics and crypto is more focused on just hiding data. It doesn't matter if it looks like I've hidden data or not. Stego, we want it to look like it's just a normal thing. Look, this just looks like a picture, right? Like looks like Mr. Robot, right? But somewhere hidden in this is data. Or let's go to Stego 2. Download more RAM. This is even crazier.
Down the rabbit hole, it's probably a bunch of images hidden inside.
Oh,
images.
yeah, maybe.
Yeah, definitely, because onions have layers.
Confirmed.
The next one's probably like a picture of Shrek or something. That's impressive. Like, you really, just looks like a JPEG. But the thing with, so like JPEGs, everybody knows what JPEG is, right? It's a picture format. It's called a lossy compression format, which means like when you compress it, you lose information. And you can kind of see that like here. You see there's some like weird colors. I don't know how visible it is, especially with the whiteboard erasing. Yeah, that's not really that visible, I guess. But the problem with JPEG is once you compress an image using JPEG, like what used to be perfectly white, if it's like right next to a different color, like that pixel might be changed or something. So there are a lot of imperfections in JPEGs that if you could just change each pixel by like 1 bit and a human wouldn't notice, which means that you can use all those pixels to really sparsely store data on them. And it changes the colors slightly, but a human wouldn't really be able to notice those
The
changes.
computer file videos on JPEG are really, really good.
Really?
Yeah. They explain pretty subtly how it works.
Yeah. Hey.
It basically stores a ton of data, but for the most part, for our general use, we don't really care.
Yeah. Are you here for White Hatters?
Yes.
Awesome. So I just got wrapped up with my talk, but I posted the slides. Are you on our Slack?
Yes, I'm Kenneth.
Oh, okay, awesome. Yeah. So I posted a link in exploitation meeting.
Okay.
And then I was just introducing CTF that just started today. I think it goes for approximately a week. So yeah, I totally encourage everybody to play in it. And it's better when you're a team. And that doesn't mean that you guys have to like find when y'all are available and like come to school or anything, because a lot of these things, you can just chat on Slack about it. Like, hey, I'm working on this challenge. I'm stuck on this one part. You mind taking a look or something? But we'll send out an announcement. Some of us might be meeting up over the weekend to play ICTF a little bit. Yeah. And then definitely next week is one of the biggest CTFs that we love playing in. That's Seesaw CTF. That's for Cybersecurity Awareness Week. And the qualifications for that are next weekend. Friday at, what is that, 2 p.m.? No.
Midnight minus 4?
It's 4 p.m., right?
Yeah. 8? Oh, sorry. No, it's UTC.
But local time though, right? Yeah, so it's 8 p.m. UTC, or 8 p.m. Greenwich Mean Time, which I think is 4 p.m. here in the summer.
Sounds right.
But anyway, it runs for 48 hours over the weekend. So definitely next weekend we'll be meeting up in the Hackspace to work on that, and that's
What's Hackspace?
so the Hackspace is.
I've heard this mentioned a few times when
That's where the
elite
elite hackers hang out.
So we're here in EMB, right? Let's go satellite mode. So we're here in EMB, right? You can cross Collins, that's the big road out there, Collins Boulevard, and this is the library. Go past the library. This is the education building where we have our Friday meetings. And then just northeast of that is the faculty administration office. It's that's not where the hackspace is. That is where the hackspace is. FAO. This is the FAO building, and then the exact room number I can never remember, but it's posted in the Slack channel. 168. Thanks. But yeah, if you go to Hackerspace on Slack, I think. Nope. Talkback does not say the room number.
I found it in the cyber program, so I cheated.
I should say FAO 168. I'll even. It's approximately here-ish.
You should submit a location to Google to get it on the map.
Oh, we should.
That'd be pretty cool.
And then you can make it part of your CTF challenge.
Absolutely.
Yeah, you can do it. You can do a recon
Yeah.
CTF challenge.
Like
to
that
find
one
it.
where they made you find a. Were you
Yeah. Well, I was the one
the-
that tried the Worcester one, or
where you have to find the bridge in
Oh no,
Japan?
not that one. No, the one that I participated in, you had to actually be on that college's campus to solve it.
Oh,
And I kept
really?
trying to solve it on Google Maps, and I was mad when I found that out.
Oh. For one CTF challenge I did, they gave you a picture of a bridge, and you had to go and find the name of the bridge.
Oh, that's
And
right.
it's some
yeah.
tiny little bridge. It's like maybe 20 feet wide. Little tiny thing in the middle of nowhere in Japan. And they gave you the GPS coordinates, unfortunately.
Oh, true. But yeah, totally encourage everyone to play ICTF. Yeah, tomorrow we're meeting back in END 252. So, we have our normal Friday meetings. Those are more like general body meetings. And those, a lot of times we'll have like industry speakers or, somebody will talk about some random topic related to cybersecurity. And then we have this room Thursdays, 5 to 6:30 from now on. Yeah, I mean, unless something goes wrong, like I'll always have a meeting on Thursdays. But definitely, if you guys haven't already, let's see if the website's still down. All right, I gotta figure that out. But is anybody not on our mailing list?
Probably not.
Probably not? Okay, so nope. Just gotta go to my email. Machine. Yeah, here we go. So I can drop this in our channel as well.
Sure.
In how exploitation meeting. So you can give this mailing list an email address to use, and all of our announcements always go out to the mailing list and Bullsync, and the website when it's back up. But yeah, definitely at least the mailing list. So, but yeah. That's it. Society of Competitive Programmers, which is another student organization, just started a meeting at like 6 p.m. and they're like trying to build a website right now. I think they do a lot of hackathons. If anybody is interested in like more, trying to build something as fast as possible. CTFs, we like try to break stuff in 48 hours, and hackathons try to build stuff in like 48 hours. So they're kind of cool and complementary. So they are in ENB 201, I think. So that's just downstairs. 201, yeah. I don't know where 201 is, but it's on the second floor. But it's like 23 minutes in, but they do like these competitive programming competitions as well, where you can try to test out your skills and also, really kind of hone in on your programming skills. So that's all I got. Anybody got any questions? Okay. Yeah. Again, like this stuff it's hard crap. I mean, anybody who's any amount of decent at it right now started at 0. Like I started at 0, started coming to White Hat, learned some of the stuff. I don't know, Kevin, what was it like for you?
Oh, it's rough.
It was
And
rough.
you get it, and it's fun.
Yeah, exactly. But yeah, it just takes time, practice, and just messing around with stuff. So yeah, hope to see you guys tomorrow. Thanks for coming out. Yeah.
Hey, can you just run by me like all of the channels on Slack that you guys have?
Oh yeah, so you can view all the channels. So if you go to this channel button, you can view all these channels. You probably won't see some of the ones with locks, but you can preview each one, and it'll show you the topic. And I think, see more details. Yeah, it'll give you a purpose and a topic, so you can figure out what that channel is for. And then, yeah, just anything that you think would have conversations that you're interested in. I gotta edit this.
Where'd you say that you posted the slides at? And which channel?
The slides, yeah, exploitation meeting, yeah.
Okay.
How do I edit the purpose? Okay. 5 p.m. EFB 337. It's not Tuesday, it's Thursdays. And that's not relevant. But this GitHub link, I put all of my any samples that I show during the meeting is there. And yeah, Kevin gave a couple talks last semester, and I hope he does again this semester. Yeah, just any like actual demos or challenges or anything will go to that link.
Yeah, just have the format straight.
Anything else? Yeah.
So what does CTF stand for exactly?
Capture the flag.
Okay, that's what-
So you familiar with like traditional capture the
Yeah.
flag? Right. So it's the same thing, except you're not stealing physical flags. You're getting programs to reveal secrets, or you're getting programs to allow you to control them in ways you weren't supposed to control them. Or you're breaking some cryptography or something, and then it'll give you a flag, which is basically a proof that you completed a challenge. And you submit, and it's just a string. So a flag in this sense is just a string of characters, and you submit that to an online board
Okay.
to prove that you solved the challenge, and then you get points.
Okay.
So it's kind of like the answer to the challenge, if the
Okay.
challenge is a question.
And how would I practice this exactly?
So there are a couple great links. When the website's back up, if you go there, one of the tabs says new members. So there's some great there's some great resources there. There's also a website called honable.kr, which this one goes easy to hard. And the first 2 or 3 challenges can be easy or medium depending on what knowledge or trivia you have ahead of time, but it gets hard really fast. So there's also, on YouTube, there's a channel I really like called Live Overflow. And if you sort his videos from oldest to newest, he's numbered a bunch of his videos, and if you watch them in order, the first 10 or 15 of them are really great for getting started.
And he literally starts with how to use Python, how to use C, how to use the terminal.
That's awesome, yeah. So,
They added 2 new challenges to Honable.
It's a
Did
good
they
starting
really?
point.
Yeah.
what else? Oh, there's, if you Google Bandit War Game,
Oh, over the wire.
Over the wire, yeah, exactly. That gets you started with some of the basics of like the command line foo. that you might need. I don't know. Anybody else have some good resources?
Got Bandit. Oh, this is a really simple one, but it's one we played at the boot camp that we did for high school students, and it's I'll give you a minute, I'll look it up.
Hack This Website is a vulnerable website that you unlock you complete a challenge and unlock the next level by coding that web page in some sort of way. You send some string that exploits some. I don't know. I don't remember what the challenges were like for that, but I think they start out doable.
Terminus is the one we did for high school students that just teaches you the command lines. It's a really nice intro. It's got a cool like adventure game style to it, like a story and stuff. So it's pretty neat.
One really great resource, especially if you're working on some public challenge and you're just kind of stuck on something, is where'd we go? Pound Channel. Yeah, if you're like working on a pwnable challenge and you're like, I got to this point, but I can't figure out like what to do after that, just ask. There are like 200 people in there, and one of them's going to be willing to give a hint or something. Yeah, and CTFs. Just playing CTFs, and then even if you couldn't figure out what to do in a challenge, people will submit write-ups. Like, oh, hey, here's how I solved this challenge. So if you go to ctftime.org, one of the first things you'll see, if you scroll to the bottom, is just the newly submitted write-ups. But you can also go to a specific CTF, like let's say, oh, I played Tokyo Westerns, and I go to event tasks and write-ups, and there's this one challenge called Load. I want to read the write-ups for it. So there's 6 write-ups available, and then they're just links, so I can click it. That's a really bad write-up. Let's go to the one with the 5.0 rating. So this is a very in-depth write-up about how this guy solved the challenge. So even if you can figure out what to do, just wait a few days after the end of the CTF and look for some write-ups. That's one of the best ways, because that'll show you what you could have done when you got stuck, so that like in the future that's one less way to get stuck. So yeah. Anything else? All right. Thanks for coming, guys.
Oh,